Okay, so this is a bit of a shift of gear, but what I'm going to talk about is actually connected, of course, to the whole framework of IIT, and in particular, with the fact that when we then go all the other way from the substrate and considerations about its macro units, and we look at phenomenology, the two things in the end have to match with each other, right? They have to be consistent with each other. So in this presentation, I'm going to talk about how to characterize contents of experience. In particular, I'm going to focus on space because this is one of the first examples of the framework of IIT applied to a content of experience in some extent. I will say something about time if I have time, and there's never time for time. And then hopefully I want to conclude in any case with some remarks about structure in general and how to account for the structure of experience with the IIT framework. But this is going to be more of a little appetizer. I hope we can talk more about all these things during these days and also next week. One experiment I want to do is that I know some of you probably read the space paper and tried to understand it, and also reported back that it is very hard. That's also my experience. We spent quite a lot of time with Jeremiah and Bjorn and other people trying to develop an account or a presentation of the space account for the IIT Wiki that tries to be really more explanatory in the sense of using examples and guiding the reader through some thought experiments and even just like literal example and analogies to make the space story a little more understandable. And I'm very happy to receive feedback if you think that this works better or it doesn't. So hopefully we can talk about that. It's going to be a little experiential, like a little experiential session. So first, I remind you of the general IIT method. We start from a phenomenal structure, which is an experience, a moment of experience, a global quale. And then if IIT is correct, it has this conjecture that it should be accounted for in full by a cause-effect structure unfolded from the substrate of consciousness. This is about an experience as a whole, right? But when we try to account for specific contents of experience, what we do is that we isolate what we call the essential properties of an accidental property of experience. So whatever are the properties that really characterize something as spatial in our experience. And then we try to do exactly the same methodology applied to a content of experience, mapping its property, formulating these properties first in phenomenal terms with introspection. And then we look at, it varies between contents of experience, but usually we look at some potential candidate substrate. We unfold a usually highly simplified model of this substrate, and then we check whether we can establish a correspondence between the properties of the content of experience and the properties of the cause-effect structure unfolded from this substrate. I want to highlight that in this case, the substrate is really a subset of the real substrate of consciousness, and what we should see the cause-effect structure as should be a substructure of the general cause-effect structure. So for the specific case of space, I invite you, of course, to consult the space paper that was published by Giulio and Andrew in 2019, and you will immediately see that the substrate that is analyzed is a grid, meaning a set of units with lateral connections that are not directional. They are undirected connections, meaning lateral connections have the same weights. And this is a 1D grid. When we think about the substrate of consciousness in the brain, and in particular of visual experience, of course, we have a lot of knowledge about visual cortex, and there is evidence that its architecture is grid-like. It's a lattice, let's say a 2D lattice of laterally connected units. They can be neuron, they can be mini columns. This is a connection to the previous talk, of course. And what we want to say is that we actually tried to find the simplest possible type of substrate that can exhibit properties that account for the property of space. And so that's why a 1D grid is actually enough. And the results that you get from a 1D grid can be generalized to 2D grids. So we can talk about this later. Yep. Right. Turn what? Oh, wait. I'm muted?
Maybe.
Ah, sorry.
That's one. Okay. Oh, that's one.
Okay. Okay, so now we are going to immerse ourselves in the phenomenology of visual space. And what I ask you is to just admire the dark screen. This is all we need to actually explain space. And there are a couple of points that I want to highlight, which are interestingly very well, they're not counterintuitive, but they definitely have been underappreciated in the history of philosophy and phenomenology. And these points are that space is actually as qualitative as many other contents of experience, like color. That space, in order to experience space, we must be experiencing a lot of spots, and that these spots must be related in very specific ways to contribute to our experience, the experience of extendedness. So the first point is that there is something to experience the dark screen. And of course, the screen could be red, green, blue, it could be black, but it would still be extended. And there is something it is like to experience something as extended, regardless of the properties, the local qualities or narrow qualia that are actually bound to this extension. And to realize that this is the case, you can think about the fact that yeah, exactly. So there is something, it is like to see colors in space, but the fact that space feels extended, it's separate from the fact that there are colors. And you can think, for instance, why when I feel a smell, it doesn't feel located in a space. So the fact that a modality like smell is spatial or not, or there is some extended qualitative aspect of it, is a qualitative fact of that modality that distinguishes, for instance, olfaction from vision. And the same goes for audition or somatosensory space. So yes, please.
But can the space feel like something if you take a qual on it? Because, for example, if we hear sound, yes, sound is spatial as vision is color also can be spatial as vision. And that's when you say, yeah, space feels something. But if you remove those other calls that are belonging to other calls, even nothing, is there still something that feels like spatial extended?
Yeah, this is a very good question. And it connects to yesterday's point. I think at least Jeremy and somebody else in that group brought up the question whether for visual space, it might be the case that we can only experience visual space in practice, like it's a contingent fact that we always experience visual space as also colored. Like in this case, I'm using the example of it's black. There's nothing on the screen, you just see an extension, but it is colored, it is black in this case. But you can think about other examples, maybe in your phenomenology, where you can feel extendedness that is not filled by any quality that is bound to a specific location. Two examples off the top of my head are, well, one, you can actually think about your experience of the body, like somatosensory space. And you can imagine when you are, let's say, in a sensory deprivation tank, where there is actually no tactile feeling, that is neither an itch or a pain or a difference in temperature. You're just feeling you have the feeling that you have an extended body, and maybe you know where it is located in space. Maybe that is a little closer to an experience of pure extendedness without any quality that feels the locations. It could be in one case. Of course, you can argue, well, I'm always having some feeling on my skin or inside my body, but in principle, it's at least conceivable that the two experiences could be dissociated, right? You can feel something as extended without being filled by anything. We can talk more about that. Like, that is an interesting question.
This is a little bit related to the question that I posed to you guys yesterday or 2 days ago. What is zero in the color?
Mhm.
This is not zero, right? And also, even gray screen for the character, that's also definitely not zero. And then closing your eyes, is it zero color? I don't think so. I mean, maybe even you have a different kind of opinion, but what is zero for color? If that doesn't exist, then always some kind of feeling associated.
Yeah.
Something.
Yeah. So this is a good insight. But I really want to clarify that even though you cannot experience space that is not somehow colored, you can abstract the spatial properties, the spatial aspect of your visual experience from what fills the space. And one way to see it is that besides colors, you can also see an object in space, and you can see just a uniform extension. See another object located in a different location, but you can abstract away the purely spatial relations of whatever the space is filled with. And that really tells you that there is something about this particular modality and this particular set of qualities that can fill this modality that is purely spatial. Yeah.
Those are high, just sit there and thoughts pop up. I have this impression that some thought popped up on the left and another on the right. There's always a space. Somehow.
Yes. Yeah, that's a very good intuition, and I think it connects to the fact that space is really pervasive in our experience. Like when we talk about time, we spatialize it. When we talk about thoughts and ideas, we use spatial metaphors and visual metaphors very often, probably because it is so pervasive in our experience, right?
But of course, we also don't take the limit, so even in the complete dark, when as dark as you can make it, there's still a spontaneous photoreceptor construction, right, called Eigenbau, concrete. So that's always present. And for any sensory system, that always has to be present.
Yeah.
So I don't know whether that corresponds to your civil, the Eigenbau.
I don't think it's zero. So the zero needs to be defined through some kind of operation as well.
Yeah, so the operation would be in a complete dark room, no photons for a particular interval.
Well, that's your explanation. So the intrinsic external operation. Yeah, with respect to the output. But do you want to complete this demonstration
Sure.
first and then take some questions?
Yeah, sure. Okay. That's a good idea. Yeah, that's a good idea. Okay, so how do we characterize the feeling of space? We have to use a lot of tricks because like we just said, we have to use color and contents of space to actually abstract away everything that is irrelevant to get to the essence of space. But one way to do it is that, like we said before, you can see a lot of things in space, and so to speak, you have a lot of bright dots in this moment. Some are big, some are small, some are here, some are there. But when I sort of make them disappear, you realize that, of course, the space, the spot at which they were is still there. Now it's dark, but it is still there. And we can now get progressively creative with analogies and try to really get to the essence of what does it mean to see, to experience a region of space as extended. And the first property that I was mentioning is that, well, it must be made of spots, regardless of what is bound to these spots, like a color or a shape or an object. But there must be spots that are filling this region. What would it mean to not have spots, not even experience any kind of spatial spot that composes a region? Well, it would really mean that there would be no space there. And so if we were seeing two bright dots at a distance before, separated by this region of space that was white, and not only we were removing the white, but we were removing all the spots, then how could we possibly see a distance between these two bright dots? Here, of course, we are using this trick of collapsing the space and showing some gray thing outside that you wouldn't really experience if you were to experience only the dark part as the space.
Spot, you really need finite, these are not infinite points.
No, spot. Yes, a spot can be any size, any region of space that you somehow experience as a separate region, yes.
But there is a lower bound.
Yes, yes, yes. There is a lower bound, and this of course comes from.
The lower bound is the claim on
Yeah.
the receptor.
Yes, 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 yes,
Let's come back
yes,
to
yes,
the
yes,
chakra.
yes, 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 yes. So okay, so now we want to bring back the spots and bring back this wide regional space. But there is, so I hope, I mean, so far I tried to argue that in order to see space, it must be composed of components, and we call them these components spots, just for lack of a better term. But this is not enough, of course, because if we had spots, but they weren't actually related in some very specific ways, then what would happen is that these spots would not form a space. They would just be, components that, in this case, I'm using another trick, meaning I am spreading them out. I am unrelated them. But you can sort of see, I hope the intuition pump is that the region of space that you were seeing that was composed of all these spots now is nowhere to be found. It's just like a scattered cloud of things that are unrelated. So space is as qualitative as other quantities of experience, but it is also essentially relational in the sense that you must have that the components of space, the spots, are related in very specific ways. Well, what are these ways? In the space paper, the argument is that there are 4 properties that need to be satisfied by phenomenal distinctions in the way they relate to each other in order to give you the experience of space such as we have in the visual field. And the first property is reflexivity, meaning that every spot relates to itself. This property is a little maybe hard to account for, but if you think about that, regions of space are very, very static, very solid. They just stay there. They don't go anywhere. This is very different from time, for instance. A moment fleets. It's very hard to introspect because it constantly fleets away, points to something else. But regions of space are reflexive. Yeah, I mean, by reflexive, we mean there's a strong self-relation. There is the, yeah, exactly. And you can also consider the fact that when you see a region, you look at a region, it seems to be, yeah, it seems to be stable in your experience in a way that it overlaps with itself, like all these kind of ways to characterize regions of space and components have been, of course, used also in mathematics. Did you have a question?
You're saying this about the relations between the cause-effect structure?
So far, I'm talking about phenomenology. We will get to the cause-effect structure eventually, but yes, this is a way to characterize the components of the experience of space, and then also contrast it to other contents of experience to clarify. Well, so, I mean, I think
It doesn't apply to tones or smells or.
I don't think so. I don't think so. Or at least if there is something in other modalities, but they are also usually spatial. So I can think about spots in my body, so in the sort of volume of my body or on my skin, but it is the same type of extendedness. I haven't finished it, but I'll get there. Okay, so the other properties are, and so I really care about this part because I know that, like with Davide, for instance, we talked a lot about the fact that, and even David Chalmers brought up many, many times, if I look at my spatial experience, I don't see any inclusion, connection, fusion, reflexivity. This is just not something that I experience. But so in the presentation that we created for the week, we really tried to use the method of IIT that is also applied to the reasoning about the axioms of trying to negate a claim about phenomenology and see what the result is. So for inclusion, I really invite you to think about this. It must be true that for something to feel like a spot that composes an experience of an extended space, it must be included and it must include other spots. So what I'm trying to say is that if you focus your attention on any part of your visual field that feels extended, it's always included by a bigger spot. And why is it the case? Well, if you think about it, is that if this wasn't the case, then this region would feel like the entire space. If you focus your attention on the entire visual field, then yes, it's not included by anything else. But if every spot in your visual field was like that, then how could you possibly be experiencing a space that has this nested structure, right? Where you can highlight smaller regions, bigger regions, and this seems to be a key property of a space, of something extended. And similarly, if a region, if a spot wasn't also including some other spots, then how could you possibly experience it as extended, meaning having a left side and a right side? It would just like collapse into a point, like there would be only points. So these are ways to try to, bootstrap our intuition about the essential properties of space by negation, so via negativum, like the good old philosophers used to do in medieval times. So a second property, a third property after reflexivity and inclusion is connection. And again, we can think we can use this type of intuition that we can try to negate the property and realize that every time, so even with inclusion, we have an inclusion structure, we have some nesting, but to feel that some regions are neighbors to each other, are closer or further away from each other, we really need to be able to experience that some of them are related. And in IIT, like relation means there is a direct overlap in this case between two regions, right? That's at least the most direct way in which two things can be related. And you can imagine again, what would happen if, so the claim here is that regions are always connected to other regions, which means that they partially overlap, and their overlap is also a spot. What would happen if spots never connected? Well, if in the limit, you could only experience them as being next to each other, but even experiencing them as next to each other would mean that they are close, so somehow they're touching or they are indirectly related by something that overlaps with both. I'll just go, this is the final property, which is fusion, which is the idea that for every two spots that are connected, they always fuse. So every time you experience two spots that partially overlap, you also experience the union of the two as a spot. And the idea here is that if you weren't able to experience this, then space would be fragmented. I think it's much more intuitive to think about the fact that, let's say you imagine you were experiencing the full visual field, and you were able to think about the left side, focus your attention on the left side of the visual field, but not the right side. So you weren't actually experiencing the right side as the counterpart of the left side, but you were experiencing both the left side and the full visual field. Well, that would be a very strange space. It would be a space where when you zoom in, you would lose parts of the space. It would have not even holes because you would not be able to experience a subregion of space. This is not how visual space works, right? So just to recap this part, there is something it is like to have a spatial experience. We must be experiencing spots, and indeed a huge number of spots if you think about the extent of your visual field and the resolution of what you can actually see. And then these spots must be related in these four ways. Okay, that's the end of one part.
So you say that every spot must include other spots?
Yes, of course there are exceptions, like the points, the pixels are the smallest possible spots that you can experience that don't include any other spot. So in this case, in the case of visual space, they would be specks of color, like little pixels that really, I mean, you still experience them, but you don't experience them as extended in the sense that you can't resolve a left side and the right side, for instance.
It's a non-extended spot.
Well, I mean, it depends if you want to call them spots or points. Like you could say there are points, you can experience points. They're not dimensionless because you see them, but they don't have internal, there's no internal region. And on the counterpart is also the total spot is not included by anything, but it only includes things and it doesn't connect to anything. Yeah.
Wait.
I have a question. You're describing something close to what in mathematics is called topology.
There you go. Yes. That's an excellent question. I mean, should we think that our experience comes from topology, or that topology comes from our experience. So, you know, in philosophy, there is a big tradition of arguing whether mathematics is, where does it come from? Is there a Platonic realm, or actually is it grounded in our phenomenology and experience, and even the type of mechanism that allow us to conceive of the world and experience the world, but also just have an internal experience of some sort? Well, the idea of IIT is really that, yes, I mean, we came up with topology, and in a sense, even the type of topology is usually 2D, it's usually Euclidean, et cetera, probably because this is based on the bulk of our experience being like that. But of course, we can conceive of other topologies that yeah. But yeah, it's a great question. We can talk more about that.
Related question is that this is lattice structure, which is of course related to the structure. But also very interesting is that this structure is also appeared in the Hilbert space structure. So-called quantum logic kind of thing has also this kind of structure. And I strongly suspect that sometimes if the classicality type thing is old, this is just a Boolean. But in general, maybe our experience, something that quantum means a normal meter mean. But if you focus on this, then this kind of structure seems to be natural. So, of course, the Boolean lattice is a typical example of the lattice, but maybe our phenomenology maybe more suitable for such kind of lattice approach.
Yeah, thank you. This is very interesting. Actually, there is some talk with Alex and Masafumi and Uneki and Francesco to actually, so this is an initial exploratory account of space, but of course, the phenomenology and psychophysics of spatial experience in the visual field can really dig into the specific geometry, the specific type of topology, and there's psychophysics that tells you, tries to basically inspect whether visual space is flat or curved, whether it is 2D, 3D, 2.5D, like all these sorts of considerations are important. Here, this is just a proof of concept that this type of account can be used to begin to account for space.
Just a short remark is that about this quantum logic or modular lattice structure versus Boolean structure could be tested psychophysically. I think there can be an experiment, especially withdrawing attention. After that, the unattended space could be more like modular lattice than this kind of classical lattice. That's something that we can think about for the second big project, I think.
Yes. Can I say something about this? So another thing that is important, and I think is one of the ways in which IIT can be validated, usually, like I said, the first day, some people think about immediately PCI or some more hands-on type of validation. But this type of validation is very interesting because one thing that one could do is to, in this case, we just used simple grids, like 2D grids, undirected connections, or 1D grids. And we get some sort of topology, and then one can check whether the architecture of visual cortex seems to match with this. But another thing one could do is that if you have a strong intuition that phenomenology has some properties, before looking at the substrate, you can actually come up with a model of a graph that would produce a cause-effect structure that matches with the properties of phenomenology that you think are important, and then look whether it actually resembles the neural substrate of, or the connections in visual cortex, something like that. So you can do the computational sort of like arc first, and then check whether you find a cause-effect structure that matches experience, and then make a prediction about the substrate.
Any related question?
Yeah. Sure. There is some really important distinction between the logics and medicine, which is, well, in practice, if we assume that we perceive the classical world to quantum effects, the coherence of all the subtleties of quantum theory are inaccessible, then our logic should look classical, like intuitionist, and the topologies are precisely the objects in which you can interpret intuitionist logic. Okay? So if you devise some psychophysical experiment that shows that in the brain you have a different kind of logic, that would be interesting. It would show that there's some effect there. But that would not be related to having a notion of space. The notion of space depends on having this sort of lattice. Because you can turn things around from the lattice of open sets. You can recreate points. And so this is a basic fact of topology. So this is very interesting. These two remarks, because that is a crossing line between being a classical world and being.
Thanks. Yeah, that's very interesting. I think Oshin, had some.
No. Then first you have a trick. Yeah.
Oh.
Okay. So you have been saying for points to exist in the visual space, they must have four relations with other points. If these relations do not exist, it won't be a different experience. So relations are essential for space to do the way.
Yes. I just want to clarify. I wouldn't say points, because points are a limit case. They are an exception, but let's say spots. So spots are anything between points and the full space. But yes, a spot is a paradigmatic component of space that feels extended, and it must have these four types of relations with other spots. Correct. Yeah.
No.
So the four principles that you have for the common structure seem quite general. But I was wondering, have you checked, for instance, some people have experiences with kind of non-Euclidean geometry, hyperbolic geometry. For instance, it seems to be pretty well documented now when people have GPT experiences. And so I'm wondering, have you checked those type of geometries to see do all of those four principles still hold in the same manner?
Well, this is a good question. I don't think these properties would fail, but the specific way in which the geometry is, so to speak, a further, like it's some structure that defines distances and curvature, but these properties are still correct. So this just gives you a topology. Is not necessarily Euclidean in the sense that that is a result of the actual type of lattice that you use, but these properties are even on a spherical space, so to speak, this would still apply. But we can talk more about that. That's an interesting question.
So you were categorical. I'm still unconvinced that the space is in any way valuable, because and I think with this, I want to say it's really valuable that you do this investigation in terms of IIT, because it goes to a very central remark about what conscious experience is. Are conscious mental states composed of nothing but quality? I think the answer is definitely no. We definitely need quality of them as we're going to be conscious states. But if there will be nothing but quality, totally structured quality. You need spots of red to be, well, out of shape, otherwise it will be impossible to separate from anything else. To see two colors, for example, instead of just permanently just one. So, and this goes also with what Antonio Pera which was like you have for one side qualia and also relations. So I think what space is, which is necessary for conscious experiences, is a relation of qualia between qualia. So for example, just think of object recognition, like the object versus background recognition. You need some kind of frontier, which is the relation between a black qualia, the background, and a red qualia, the spot. But that relation is itself like ways of relating qualia, and therefore that's not qualia.
I would push back on that. No, in the sense that I actually agree with almost everything you said. But specifically because relations are qualia, are qualitative. What we are trying to say is that it might be true that there are no distinctions that are purely spatial, but in the case of visual space, every distinction is a color distinction. But there's a difference, and it's a qualitative difference between having an experience of color that is actually not forming an extension, like spatial, and having an experience of colors that have spatial relations. So the spatial relations are exactly the ones that give you an extension. Just to name an example that came up this morning at breakfast, think about smell. Like you can clearly experience two smells at the same time. You can smell coffee and rose, right, at the same time, but there is no spatial relation between them. It's not that one is to the left or the other. They're just like both co-experienced. Color is not like that. Color, you can't experience two colors literally overlapping, especially if they are kind of like, opposite colors. But that just tells you that space is like color is in space, whereas like smell is not. And you could conceive of an experience where there is colors, maybe more than one color. They're just not spatially related. They're just like sort of superimposed to each other like smells. This is not our experience, and it's very hard to imagine, but it's not inconceivable, right? So what we're trying to say is that in the case of space, the units might actually be color mechanisms. But the fact that they are related spatially or not, that is a further fact that needs to be accounted for. It is as qualitative, and in this case, it's largely relational. If you disrupted these fundamental patterns of way of relating, then you would lose the space, but you could still have the color, something like that. Okay.
Maybe with your fund is a bit kind of related to many of the issues we talked. So I will speak remark. Here, in the first talk I gave in the morning, I said that at least here I proposed the definition of qualia as qualitative aspects of experience. And if you say that the space is not something to do with not the experience, you can say something like that. Space is not qualia. But if you are accepting the space is something that we experience, then you need to qualify your statement as according to my definition of qualia, e-qualia, and qualia. You are proposing different kind of definition of qualia, and then you can defend it or write something in second week. But I think that's not a super kind of useful discussion to have. And then before going further, I thought that
sorry, maybe I missed this, but I feel like we're always talking on vision. So my question is now that like, okay, we are talking about visual space, and we know that our eyes are kind of window of our brain and our consciousness into the world. So I mean, I understand that, but what about our own experience in space? I mean, our own position, localization. We can describe space not only by visual cue in space. So you mentioned these four properties, but I mean, I feel like my own experience in the space is a better experience of space and the concept of space with respect to visual space.
Perspective on location in the
Yeah. So
and it's something that everybody can experience, because like blind people cannot have this kind of.
Yeah. So I hope I'll be able to touch on this at the very end. But what I remark is that in the paper that is called Consciousness as an Intrinsic Causal Structure that I shared, it's a draft. It's under revision right now. The last part is really trying to go beyond this characterization of modality-specific spaces and argue that our experience of space is, of course, always multimodal. It's this thing where we have personal space, peripersonal space, distal space, auditory space, maybe visual space, bodily space, all these proprioceptive space, all these kind of spaces are in register with each other in the sense that I see a location in the visual field, but I also feel that I can reach it with my arm, with my eyes closed, and probably we kind of agree we have a similar experience of the corner of the room. Like this is all spatial. And in our experience, it must be accounted for in similar ways. Maybe it's not 2D, but it's more like 3D. This is just an attempt to get to the simplest possible example of space that is extended and we are very familiar with. It's introspectable, visual field, but it can be generalized to other modalities. And we definitely can talk more about that. Sure. Yeah, then we can go.
If it's quick enough, otherwise we can discuss it. But you keep saying smell is not spatial, and this I'm very confused. Like even if you think the classic Disney when they make a cake and there is the trace of, and then the character flows towards the cake, right?
Yes.
So you saying like something like that is more. There are a lot of different smells that create a gradient, and so we can sort of follow the smell.
Yeah. I mean, you can navigate the environment and feel that the smell is getting stronger. But if you're blindfolded and tied to a chair, I doubt that you can say, oh, there's a smell coming from behind. But you could say there's a sound coming from here. Maybe if you're a dog, right. Like exactly like with kind of like difference in perception. So, I mean, I'm saying it's much less spatial. Maybe for dogs, actually, that is incredibly direct. I don't know, but okay. Can I go just for a little bit? just a note. Okay, so the second part, we can actually skip the details, but I mean, in principle, that's the more interesting part because you can buy the phenomenology, but then you're like, great, now what? To me, the pioneering work in accounting for space was really that this is the first example of a quantitative experience that is qualitative and structured, and there is an application of the mathematical formalism of IIT that allows you to do what IIT promises, which is to find this correspondence, this explanatory identity. So we have a collab, just a Google collab, where I basically created a small network of 7 units with the connections, and you can run it. And if you're interested in looking at that, we can do it together. And what I want to show here is just that this is one way in which I like to plot distinctions. And this is just one column is basically telling you the mechanisms, the units that are specifying the distinction, and then the cause and effect elements, and then their phi and the state. And this is the data that actually is used then to plot that thing there, the color thing. That is actually a cause effect structure, but it's just a representation with the relations of the distinctions that I just showed, and you can get from Python. But yeah, so what you can do is that you can take a grid of, in this case, small number of units with lateral connections that are undirected, and they have self loops. And now the question is, can we find a correspondence between the properties that we just talked about and relations between let's call them patterns of relations between distinctions in the cause effect structure? If we can't, then the idea is that this type of grid is not a good substrate to formulate the properties of space, phenomenal properties of space in physical terms. If it is, then we can ground further hypotheses on what these mechanisms are in the brain. Yeah. So yeah, I'm not going to go into details, but what I want to just point you at is that if you take a grid of nodes A to G with the weights that you can find in the collab, and you unfold its cause effect structure, you find distinctions that look a little bit like this, or this is a way in which we represent them. You have in black the mechanism, in red the cause, and in green the effect purview, and they have some elements in a state. In this case, the grid is all off, all the purviews are all off. And then what you can do, in this case, I am zooming into some 4 distinctions, 4 causal distinctions that are supposed to be the counterpart of the 4 spots, S1 to S4, that I've been using in the phenomenological depiction of the properties of space. And we can ask one by one, if every phenomenal distinction is reflexive, what does reflexivity look like in causal distinction terms? If every phenomenal distinction, meaning spot, must be included and include other distinctions, is it true that every causal distinction includes and is included by other distinctions, etc., etc.? And what you can see is that by just by virtue of applying the postulates of IIT, unfolding the cause effect structure, and looking at the relations, you can check whether the relations satisfy the properties of space. You don't need any additional ingredient to actually check whether this is, or to add, to make it spatial. It's either already spatial or it is not, by virtue of the substrate and the way in which it is connected and the distinctions it specifies. So, yeah.
Can you repeat the code?
Yes. So the black ball and the black label is the mechanism, which just means I'm literally taking, let's start from this one, node CDE together. I have 3 units. They have some activation function and connect self loops and connections to their neighbors. In this case, it's just a line, right? A 1D grid. So CDE together as units, if you apply the formalism of IIT, specify maximal irreducible integrated information on the cause side about unit D being off, which kind of makes sense because if you take 3 units that have lateral connections, the maximal information is probably going to be about the unit in the middle, like C, D, and E all talk about either themselves or their neighbors. And so you can say CD maximally constrains D. If it is off at this time step, it's probably was off at the previous time step, and it probably will be off at the next time step. Yes. All units are off, yes. In the space paper, there is a modeling of what happens when you turn a unit on, and possibly you even change the gain, and you deploy attention and you change the strength of the connectivity. This is not
it violates every neuroscientist intuition, because all these units, none of them
doing nothing. Yes.
Yet they create.
Yeah. And I mean, I will get to one of the counterintuitive hypotheses that are, of course, grounded.
When you see the small letter, basically
it's off. That means off. Okay, so here you can look at these distinctions. We have 4 causal distinctions that specify a cause and an effect each. And another thing that I try to point out these days that I'm getting more and more convinced that maybe we should be careful about when we talk about relations. Like in IIT, a relation is a very specific thing. It means that 2 distinctions have an overlap in the elements of their purviews that are also congruent on their state. So in this case, CDE and BCDE have a relation on both their cause and effect side over unit D, because D is included in both causes and effects of all distinctions. And the same is for CDEF. So just to mention one example, this is an instance of inclusion that applies between spot S1 and spot S3. The counterpart, the analogy is that you have distinctions like BCDE that have causes and effects over CD, and there are always other distinctions like CDE that have causes and effects only over D. So you can say there is a relation, a causal overlap between their purviews, and one distinction includes the purviews of the other distinction. So this is an example of inclusion. But you can do the same for connection and fusion, and reflexivity means that there is a self-relation between the cause and the effect of the same distinction.
This other intuition, I know it's wrong, but I just have it. There's this magic. You get 2D space. What looks to me from an extrinsic point of view is 2D space of the 1D line.
No, so well, it's actually not 2D, it's 1D. so the right side, if you really map it onto a topology, you end up with a 1D space. Here, it's just for the sake of the example that we have a 2D space on the left side and it's a 1D space on the right side. But this generalizes, of course, if I took a 2D grid, then it would be the same. Every distinction would be reflexive, but instead of having, so if I take
well, then the illustration somewhat misleading.
Yes. Well, so a schematic, yeah, exactly. So we have there's a conundrum, right? Either we show a 1D space and we try to convince people that by looking at a 1D space, this is representative of your 2D visual field, or we unfold a 2D grid. I think we should go with the latter. We should unfold the 2D grid and actually show that the fact that dimensionality of the cause effect structure actually comes out of the dimensionality of the grid, because in this cause effect structure, a distinction can only have 2 neighbors, right? Because it can only overlap either on this terminus or on this terminus. That tells you that it's 1D. But if it was actually a 2D grid, it would have multiple.
If you go to 2D with the way.
Well, it's still still would
be a 1D space.
Yes. And you can never, so for instance, the same distinction cannot overlap with 3 different distinctions on only one unit, because it's a 1D, grid. So we could try to come up with an example that is 2D for the cause effect structure. It gets incredibly more complicated, so that's why we went this way. But we hope this.
I think that's my doubt. There is such an example to the space paper and to the connection and operational why 2D. Such an example is there.
Mm-hmm. Thank you. Okay. One important thing is that, so right now I showed these relations as they apply between 4 distinctions, but of course, in order for something to feel like a space, you can argue what is the smallest possible space, how many spots are necessary and sufficient for you to feel that something is a space. But what applies to only 4 distinctions and 4 spots should really apply to the entire space. And so when you actually apply this relational analysis between all the distinctions of a cause-effect structure, even if it is just 7-node grid, you end up with a cause-effect structure. So here, I'm using this reference. You can see the symbols here. So whenever I'm looking only at the labels of the distinctions. I'm hiding the purviews, and I am showing the relation just schematically. If there is a yellow line, it means that this distinction includes this distinction. If there is an upward triangle, they fuse. A downward pink triangle, they connect. So this is what comes out of a 7-node grid, and you can already see that there are the points, the first order mechanisms. There is the full space, that is the highest order mechanism, and these are properly not extended in the sense that they violate some of the conditions, but then you already have quite a big structure where you have multiple levels. You have smaller spots and bigger spots that include each other. This just with 7 nodes on a 1D grid. So of course, if you think about visual cortex with how many units you might have, and it is 2D, you should actually expect to get something as complex, as rich as the visual field, and you can also gain insights on psychophysical investigations of the visual field, on how many spots you can actually resolve, how many, the resolution of the visual field, and try to match them with the number of units visual cortex. Yep.
In real neural system, each given neuron is connected to roughly like 1,000 neurons, right? And so this is all nothing to do with the receptive field of the neuron.
Yeah.
It's all intrinsic. Yes. So if one neuron is connected to 1,000 different kind of dimensional things, then space could be actually really humongously complicated than the 2D. Yeah. But your hope is probably, or prediction is that the connected macro scale thing, this kind of 1,000 connection doesn't matter, right? That's your kind of hope or prediction.
Oh, no, but just, you could have it at, it could be, yes, but it's a column, and so the columns only have, a smaller number than 1,000 neighbors connected to the scale.
So the effective connectivity should be like this 2D grid like structure. But if you actually find many more strong kind of effective connectivity, then that's also inconsistent with this kind of picture.
Well, I don't think it's inconsistent. One thing that came up again is that maybe for visual space, each individual, the smallest possible spot is actually a quite complex, mechanism with a lot of units that are connected to each other, and maybe that is the mechanism for color, and that's the reason why you can't see space without color. But so maybe instead of having that your space starts with points that are first order distinctions and then second order is already a spot, maybe anything below the, 10th order or 20th order is a point in space, in space terms, but it is a local quality in color terms. Yes, yes. And then from the 20th order, then you start having these relations between distinctions of higher orders that give you the spatial structure. Yeah, that's one hypothesis. Okay, so
in principle, how would you get the depth 3D, like stereo or monocular depth? Because we do a phenomenological depth, right?
Well, so this is in the space paper. There is some discussion of that. I don't want to go too far in commenting on this, but because I'm not very knowledgeable. But so first of all, it's also a simplification, of course, that you have only one grid. You have stacks of grids on top of each other with different perceptive fields. Then you have binocular, of course, you have stereoscopic vision, so you have slightly different images, and you probably have mechanisms at higher level that are producing this effect of depth. You can argue that vision really, like if you just have one eye, then the perception of depth is less, of course. If you look at a picture, you can argue that vision is mostly 2D, but the 3D is sort of like superimposed on it. Although there must be mechanisms that account for that. They might not be in the grid itself. That's all I'm trying to say.
And certainly bats can do precise 3D targeting and so on.
Yeah. Well, that's actually a good question, because does it mean that their experience of space is closer to our vision or closer to Alice's point that was maybe they have more of a 3D experience of space because sound is or like with the clicking of the blind people. Yeah. So.
It's okay to show the miracle that
the last, you mean the last talk at the end of the day, the morning? Sorry, I'm stealing. Okay, so so one important point is that the characterization of space, we talked about the essential properties of space, but then of course there are a lot of derived properties, and if the account of IIT is correct, all these derived properties should again require no additional ingredients. So by virtue of looking at the relations or patterns of relations between distinctions, we should be able to describe all the other properties of space such that every spot has a region, has a location in the space, and there are distances, relations between all the spots. So this is a little bit like to your point that like distance is not a distinction. Distance is a relation between distinctions, and that is qualitative. You feel that two things are at a specific distance without having to compute the distance, so to speak. You just look at the distance, right? So I just want to show very quickly that a region of a spot corresponds to what we call the subtext of a distinction, meaning all the distinctions that are included by the distinction give you the region of this spot, and they can be smaller or bigger in the cause-effect structure. And then similarly, one important point about distance is that there is a way to characterize distance in the cause-effect structure that is basically when two spots feel far away is because the smallest spot that they both relate to actually has a big region. So the subtext of the distinction of the smallest distinctions that partially overlap with two distinctions is big. That results in a big distance between two distinctions, two spots.
The same thing can be said for similarity.
What do you mean?
The distance bigger and similarity of the spots or color unfolded this way.
Well, this goes back to the idea that I don't think so. So a distance relation is a relation in IIT terms, or at least let's say it can be an indirect relation. Like with Hayato, we were talking about the fact that you might use this zigzag idea. You don't have a direct relation, but you can have indirect relations or higher degree relations, but it is a causal relation. A similarity judgment, that to me is something that, so if I judge the similarity between red and orange in two patches in different portions of the visual field, what I'm doing is that there is a third mechanism that is looking down. It's not a direct relation between the two, but I am introspecting, I'm making a judgment about, these two things that are not directly related. At least maybe they are related spatially because they are at a distance, but there is no similarity relation in that sense.
They can still show up. If I think about the Miller Lyer, right? You see the arrows to be different lengths. It's not you infer, it's directly.
Yeah. So
doesn't that mean there has to be a mechanism?
Well, so I'm saying you are experiencing two sizes, like the length, you experience the length, and then you are comparing them and you're experiencing this, that one looks bigger than the other, right? So it's a judgment on two length experiences you're having, but they're not literally related, the two segments with the arrows, they're not causally related except them being in the same space. You're making a judgment, and then one feels longer than the other. I'm just trying to complexify a little bit the way in which we talk about relations, because it seems to me that there's a difference between having an orange circle, literally the circle is orange and they are overlapping in phenomenology, and probably the mechanisms are causally connected. Well,
I mean, how can I test for the Miller Lyer whether that's a judgment, a secondary judgment, or whether it's a direct phenomenal?
Well, if it is a higher order judgment, maybe you. What I'm trying to say is that. So let's say.
Attention.
Yeah, exactly. So.
Withdraw attention.
I don't know. Is that not possible, maybe, to judge it anymore?
It's very possible. And the higher order, you're thinking
Yeah.
something that we can remove.
Yeah, exactly.
Withdrawing attention. Then.
Good. Very good.
Nice experiment.
Exactly.
Someone's PhD thesis. A master.
Yes, yes, yes. Okay, and then when two things are at no distance at all, it means that they are directly related, like they literally overlap, and that's why they feel it's literally next to each other. Yes.
So this is a bit of a more big picture question, but I have been thinking about whether there's any possible any non-human animals or artificial systems that doesn't have this spatial prediction or this extendedness aspect, and I can relate to that, and I wonder whether if there's any agent separated from something, an external or something, is this extendedness actually inherently necessary? Like if you have separation between things, and that other things like the external world by definition needs to be extended.
Yes, this is a very interesting question. I don't know the answer, but I thought about something similar. I mean, oftentimes in even the neurophenomenology literature, or even just like developmental, biology, like you consider the fact that usually the first thing that very simple animals, probably the main sensory modalities that are developed first are some form of somatosensory, kind of like detection, tactile detection, and maybe olfaction, some sort of like chemoception. And I think this is important because we are in a world that has a spatial structure, right? Things are close or far from each other, and we want to be able to detect directions and neighborhood relations, this kind of thing. So yes, it might be one of the most basic types of kinds of experiences. Yes, I agree with that, but this is just a comment. Shall we? Yes. Okay. So, right. Okay. Let's see. I want to say that this definition of space is intrinsic, and of course, one important point is to realize that you can dissociate spatial functions. Like maybe you have some animals or some artificial systems that can perform spatial functions without experiencing actually anything like extendedness of space. We had a paper where we tried to create two grids. One is actually has lateral connection, one doesn't, and one we call it a map because it can be functionally equivalent to a system that points things in space, but actually the cause effect structure is no way. There's just like independent systems that specify simple distinctions with no spatial relations compared to a grid that unfolds into a spatial extension. Yes, Melanie.
Just to tell you, Matteo, we just agree with now that I was with my talk about meditation in one flat space, so you have more snacks tomorrow. Oh. To both come back on one of the maybe not.
Oh, great. Okay. Perfect. Perfect.
So don't worry, guys.
Thank you. Thank you. Okay. So some comments about how many grids there are in the brain, and I just invite you to ask Melanie and Giulio and other people. This is probably speaking to the fact that our experience is largely spatial. There are, of course, cases where space shrinks and warps based on lesions, but also experiments that can be done with predictions about the fact that if space is a structure and every distance relation is a function of how you feel something is located in the entire space, then things like scotomas or lesions should warp the entire experience of space. And this is the topic of one of the adversarial collaborations. We can talk more about that. And the last thing that I will not talk about this, but the idea of IIT is that everything that has been done with space so far could potentially work as a template to account for different contents of experience. And of course, time is a second natural candidate. It's a second natural candidate because it is partially introspectable. It's definitely qualitative. In this case, people have recognized that time is a content of experience and it's very pervasive and important. However, we're kind of in the dark about the mechanisms that underlie the experience of time. So this is a challenging project, but we just published the time paper. So maybe you can look at that. But I want to point out that there is, sorry, I'm going to go here, that there is really symmetry between starting from the essential properties of space and time, describing them in conceptual terms, finding a candidate substrate, unfolding it, and trying to find a mapping. And I want to end by saying that this can be done for the idea of IT is this can be done for all contents of experience. The agenda of IT is to address each of these one by one and try to account for these in the same way. And we can talk more about the fact that, of course, there is a connection between the type of substructure that is specified that corresponds to a kind of content of experience and the kind of substrate that unfolds into that structure. The hypothesis is that undirected 2D grids contribute what we call extensions, which correspond to spatial extendedness. Directed 1D grids unfold into temporal flow that corresponds to the flow of time. Routed trees can account for the recognition of objects, which in this case would be they would be located in space, but and connected to narrow qualia such as color, but bind a particular set of features with a general feeling that this is a face. It's not just like this specific face. And then finally, the hypothesis is that narrow qualia such as color, pitch, tactile experiences, smells are contributed by small clicks that are highly interconnected sets of units. And of course, we have some evidence that these type of architectures are in specific areas of the brain that we also know contribute contents of experience of this sort. So it is that these would all contribute substructures of the causative structure of one experience. The list, of course, is long, and this goes, maybe connects to now's idea of the periodic table of qualia. So I will stop here, but I also want to say that there is more. Of course, this is only the basic elements. We can talk more about whether we can exhaust the set of contents only talking about these things. And here's just like some prompts for discussion. Ideas on how to better characterize specific contents of our experience from phenomenology, ideas on further investigation of mechanisms of specific contents, experimental ways to test predictions with online experiments, psychophysics, and neuroscience, and then how many kinds of graphs really we have to analyze to account for all the contents of experience. Thank you.